Hello guys. Today we'll be talking about the graphs of equations. Before we get into the first objective of the day, let's review a little bit concepts that we learned about a coordinate system. So when we talk about coordinate system, it's usually represented by the graph of x and y coordinate like this. The horizontal axis is usually the x-axis and the vertical axis should be the y-axis. Okay, we have like four legs in here. The middle one, the intersection between the x-axis and the y-axis, we call it the origin or zero. Oh, for origin, or if you want to think about it as zero, that's fine too, because it's right here, it's like zero, and if you go up on the y-axis, you're gonna have like 1, 2, 3, and so on. If you go down below zero on the y-axis, you're gonna have -1, -2, -3, and so on, right? That's the y-axis. On the right, on the x-axis, same thing will happen. If you go to the right, we will have 1, 2, 3 for the positive direction, and if you go to the left, we will have -1, -2, and -3. Okay, and how you graph it, for example, if you have the point, say, I don't know, like 1 and -2, for example, the first coordinate is always the x coordinate, and the second coordinate is always the y coordinate. Let me put that y in here. So how you plot the point is that you go to 1 on the x-axis, which is right here, but then you don't make a point there. You don't stop in there. And then you go to the y-axis, -2. So how can we connect them, right? If you want, you can think about it like dash line-ish, and wherever they intersect each other, we have a point here. Okay, or even more simpler than that. First, I'm gonna go to 1 on the x-axis, which is right here. I'll make a mark of it so you guys can see it. And then the outer coordinate is -2, so I know that I have to go down by 2 from where I am right now. So I go down 1 and 2, so the point is right here. Okay, that's a quick example. And as you can see in here, the coordinate system, it represents a relationship between two quantities. In the graph, the two quantities, they are x and y. For example, if we talk about the relationship between a student's grade and the number of hours, I'm missing a T in here, and the number of hours a student studies per week in this class. For example, that relationship is modeled by this equation right here. Let me circle it so that everyone can see it. So as you guys can see in here, x is the independent variable and y is the dependent variable. Why do I say so? Because for a random value that you plug in for x, say 0, you're gonna get like a fixed value for y, right? For example, if you plug in 0 for x, 8 times 0 plus 10, that should be 10, right? Y would be 10 if x is 0. If x is 0, y cannot be 1 or 2 or any other value because it's a fixed value, okay? So how can we graph this, right? To graph a line is actually, you only need 2 points. But to elaborate it more for the first example, in our class, let's do 4 points, okay? In fact, you can choose any number for x value that you want to. But like personally, I go by 2.5, 5, 7.5, and 10. But really, you can choose any number for x. You can choose something like 100, 200, 0, or like 8, or even fraction 1/3, or any number for x that you want to. But notice that I didn't choose any negative number, right? And that will be one of the questions that I'm gonna talk about in the next second. This question right here, why we're not going to have like negative numbers. But for now, since we have our x values already, the next step will be we plug those values in for the equation right here, or right here if you want to rewrite it, or simply you can just put y in that box if you want to, or you can write the whole equation down in that box. Doesn't really matter for me. So you plug in 2.5 into this equation right here. In the calculator, you would do 8 times 2.5 and then plus 10, okay? Parentheses or no parentheses, it really doesn't matter for this situation, but in the future, for some problems, the operation really matters the parentheses, so you might want to watch out for the parentheses, okay? And if you do it correctly on the calculator, you should get 30 for 2.5 when x is 2.5. And if you repeat the same process but for different value for x, say for x is 5, you're going to get y is 50, and for x is 7.5, then y will be 70. For x is 10, we're going to get y as 90. And after that, we're going to write them as point, and then we plot them, right? So the first point that we got in here is 2.5 for x and 30 for y. As I said from the beginning, we're not going to mix up the order between x and y. X always the first coordinate, the first number you write on the point, and then y is always the second number of the point. Don't ever write y first and x second. That's wrong, okay? That's a big no-no. And we're going to repeat the same process for the second point, the third point, and also the fourth point, okay? And after that, we're going to connect all the points together as a line. So we're going to get this blue line here. Let me trace it again. I'm not going to make a beautiful line, but there we go. And if you guys can do me a favor and just, like write a little note so that I can know that the equation for this line here is y equals to ax plus 10, that'd be great. If you leave it blank and you just draw the line, that's fine too, but in a test, make sure you just, like the more you write, the better, right? You don't want to lose any partial points. And let's talk about a question that I asked you guys earlier. Why don't we have negative numbers on the axis? Well, actually, earlier I asked you, why don't we have any negative numbers on the x value, right? But now it's more specific when you see the x-axis and the y-axis here only contain positive numbers. We don't have negative numbers whatsoever here. Why is that so? I mean, in real life application problems, right, we're not going to have like negative numbers. Say, if I ask you how long is that wood, or like how long is your pencil, you're not going to tell me, oh, my pencil is like -1 centimeters, right? If I'm asking you like how many hours you study for a week, you're not going to tell me, oh, I study for -5 hours, right? Negative numbers are okay in math concepts, but like in real life problems, they wouldn't make too much sense, okay? That's why I put the answer in here. The numbers of hours and grade cannot be negative, okay? And as for the second question, how can we interpret this graph? If we want to get an A, like a letter grade A in this class, how many hours should we study per week? So math is important in the sense that we don't only just do the math, like we don't only just do the work, graph it, and then stop right there. We have to know what we're doing, right? We have to know the meaning behind all the work that we're doing. So we have the graph ready. First of all, what we notice here is that the line from left to right, it's increasing, right? It's increasing in here, and it increases from like low to high. What does it tell you in here? It tells you that the more hours you study for the class, the higher grade you would get, okay? And more specifically, if you want to get an A and above, at least you have to study 10 hours for this class, okay? So that's the answer I put in there. And now let's move on to the first objective of the day, the graph of an equation. So frequently a relationship between two quantities, x and y, or like in real life problem, it depends on the problem, is expressed as an equation. In the last example, we have the equation of y equals to ax plus 10 or something like that. In the book, you will see more equation like this, or just an equation that has like x and y. And the tips in here is that we call it equation because it has the equal sign, so equal and then equation. The graph of an equation is to set up all the points that are solutions of the equation. So let's go back to the example that we did earlier. So if you still remember this example right here, we cannot plug in all the values of x that we have, right? It will take like forever and it's not going to go anywhere. Like the more points we have in there, we're going to plot more points in there and they all will connect to just one blue line there or red line that I just traced. Okay, so like there's no point of doing that, to be honest. And I told you before, you don't have to go with the same set of x value that I chose in here. You can go for different values. You don't have to go for like 5 or 7.5 or even 10 in here. You can do 2, 3, 4, any numbers that you want to, right? Like any person, like everyone has different set of numbers in there, but we all should have the same line. We all should have the same graph of the same equation. That's what it means by the set of all points in there, because it contains like all the points, the points that we chose and the points that we didn't even use. They all will show in the line. Okay. And as for the word solution, each of the point here are the solution of the equation right here. Why do I say so? Because if I plug in 2.5 for x and 30 for y, I would have something that match out with each other. I would have the left hand side equals to 30 and the right hand side of the equation also equals to 30. Okay. If I give you another point, say, I don't know, like 0 and 1, and I ask you whether this point in here is the solution of this equation right here or no, the answer will be no. This point is not a solution of the equation. Why is that so? Because when you plug in 0 for x on the right hand side of the equation, we will get a times 0 plus 10, which is 10. Meanwhile, on the left hand side of the equation, we will have y, which is 1. And we all know that 1 is not equal to 10, right? That's why 0, 1, the point here, is not a solution of the equation in here. Okay. Now, getting back to the slide that we on. So some tips, whenever you see like this symbol of like the 3 asterisks or like this 3 stars, whatever you want to call it, it's like my notes, like my personal advice or my personal tips for you guys. So for point plotting technique, the technique that we just use, going by like XY table, you choose different value for x, then you get different value for y's, and then you plot the points, and then you connect all the points together to get the line. That's what we call by the point plotting technique. You know, like we just plot the points and connect them. That's why like the name is quite simple. So this technique is really easy to use. Anyone can use it. It doesn't like require like high technique or anything like that, but it has some shortcomings. For example, with too few solution points, you can badly misinterpret the graph of a given equation. I mean, like for a line, if you don't have like power on x or y, it should be simple, right? Like you just need like plot 2 points and there you go, there's a graph. But for example, if you have like x squared like this, or like later on in the future, you might have something as ugly as like square root of, I don't know, like x plus 1, or something bad as y equals to like 1 over x square, something like that. Something is not as simple or as lovely as just x plus 1 or like some x and some number. Then it might be hard to get the graph just by plotting points. Okay, for example, if we go for 4 points in here, the graph could be like this, or it could be like this, or it could be like this. If you notice, the position of the 4 points, they don't change, right? But how you interpret the graph or how you draw the graph is really different. And for each of the graphs in here, they all look different, right? But the equations, we don't know. We have no idea what the equation looks like. So we have no idea which of the 3 graphs in here are the right solution of the 4 points that we plot from the beginning. That's why this is one of the shortcomings that the point plotting technique has. Okay. All right. So For the next example, for the first example, I want you guys to try to sketch a graph of the equation y equals to negative x squared plus 3. A heads up is that it will look like a U shape. It's going to look like a parabola, if you guys know what I'm talking about. If not, later on we're going to talk about it. We're going to learn about the parabola in the future too. So technically it's going to have the U shape, either like a U, a proper U, or upside down U like this. Okay? How do I know that? Because I have the 2 on the power of x. Okay? If you notice in the last example that we did in here, this equation is really lovely. On x and on y, there's no power, right? There's no like x to the something. There's no y to the something. It's just x and y and some extra number. Okay, so to help you guys get the right graph from the beginning of the example, I specifically go for the set of x value. Why do I choose negative numbers now? First is because of the symmetry of the parabola. You will see it the moment you get all the points and graph it. You will see some symmetry going on in the graph. And secondly, when it comes to parabola, when it comes to x squared in general, I would recommend using the set of x value. It will have like 5 points in here. 0 would be the center. And the point of negative 1 and 1, they should be like symmetric to each other. Same thing with negative 2 and 2. They should be symmetric to each other. You will see it in the graph. Okay, so your first mission of the day is to fill out this blank in here, all the y values, and after that, plot the points of x and y, connect them to get a U shape. Okay, so recap of the first objective. For linear equation, any equation of the form y equals to mx plus b, we only need 2 points, of any x values of your choice. It could be anything. To sketch a graph, and the graph of a linear equation looks like a line. That's why they call it linear, because, line and linear, adjective form of it. And then it rises if m is greater than 0. And what is m, right? M is the slope, or whatever number is in front of x. We will have like 2 numbers, if you notice, in the linear equation. We will have like a number that attach to x and a free number that, like is free. It doesn't attach to anything. It's just, it's free. It's the loner, And the line, the graph, it will fall if m is negative. To demonstrate that, let's go back to the first example, the very first example that we did in here. Know that the m in here is 8, because 8 is the number is attached to x, right? It's positive, right? It's greater than 0. It's positive. That's why we have a rising line. If 8 in here, for example, is some other number that's negative, say negative 2 or negative 3, we'll have a falling line like this. Okay? And if you have like m, and if you ever have the case when m equals to 0, we're going to have a flat line, like a horizontal flat line. Okay? But for now, you don't have to mind all of that information. We're going to talk more about it in the next sections. Okay, and as for parabola, as for quadratic equations, any equation that looks like something that have x squared and even x and other numbers, like the example that we did in here, know that in the example, for the example 1, there's no b, right? Because there's no x. Actually, you can understand it as b equal to 0, because 0x is just 0 and 0 is nothing, right? That's why we don't write there. If you want to make it like like proper, look like the form, then you can write equation in the example 1 like negative 1 x squared and then plus 0x and then plus 3. So negative 1 in here is a, 0 in here is b, and 3 in here is c. Okay? Any equation of this form in here where a is different than 0, think about it. If a is ever 0, then you're going to get the line y equals to bx plus c. And in here, if you notice it, y, there's no power on y or x. That means that this is a linear equation. It's not quadratic anymore. That's why we have to say from the beginning that a has to be different than 0. Okay? For this kind of equation, we're going to need 5 points. And I would recommend this set of 5 points. The set of x equal to -2, -1, 0, 1, and 2. Okay? Once you get the x values right there, you're going to plug it into the equation to get the y values. After that, you're going to plot the points of x and y. After that, you try to connect all the points together in a U shape. It's going to be an upward U shape if a is greater than 0. Or if you do the right procedure in example 1, it will be a downward U shape, because in this example we have a equals to -1, which is like less than 0. Okay, and U shape is just like, English, but in mathematical terms we call it parabola. Okay, so again, just really quick, for equation we're gonna have the word linear. The graph of it, we call it the line. And for equation, we also have quadratic, but the graph of it, we call it parabola. Okay, make sure you don't mix up between the graph and the equation names. All right, next objective of the day. Now we're going to talk about the intercepts of the graph. So what does it mean by intercepts, right? Intercepts in here is just like intersect. So think about the intersection of the street. So for example, if you have like if you go to the street line, you have an intersection like this, right? Here, let me draw it better. So just imagine this is like the street. We call this an intersection because think about like this vertical street as like a line, and then this horizontal street as like another line, and you're gonna get an XY coordinate system. Okay, where this one is X and the other one is Y. Okay, the intersection in here would be this big point here. Let me change the color actually to make it easier to look at. This big point here, we call it the intersection. Okay, so when we talk about the intercepts, they are different a little bit in the sense that they are points. Again, they are points, right? But they intersect only on the axis. They intersect only the x-axis or the y-axis. And obviously the x-intercept is the point or the coordinate that intersect the x-axis, and the y-intercepts are the points or the y-coordinate that intersect the y-axis. Okay, the name will tell you them all. So again, the intercept are points, but the x and y intercept, they could be point or coordinate. Okay, so if you don't have a letter in front of the word intercept, you're fine. They are just points. But if you have a letter, say x-intercept or y-intercept, they specifically tell you whether that point is the intersection of the x-axis or the y-axis. Okay, so make sure you watch out for it. And symbol-wise, x-intercept, because it intersects the x-axis, it should have the x part, while the y part would be 0. And with the same logic, for the y-intercept, since it intercepts the y-axis, it should have the y-coordinate, and the x part should be 0. Okay, for more example, here we're gonna do this. We're gonna talk about the x. We're gonna try to find the x and y intercepts of these 4 examples in here. And just a heads up, a graph may have no intercepts or several intercepts. So it doesn't have to be in the case that you only have one intercept, one x-intercept, one y-intercept, or just one intercept in general. That's not the common case. Okay. For example, the first picture in here, in terms of x-intercept, let me just write x-intercept in here. Does the graph, okay, so this is the graph, right? Does it ever intersect the x-intercept at all? I mean the x-axis at all? The answer is no, right? Because the u-shape is like way above the x-axis. So we will have 0 x-intercept. For y-intercept, since the graph, the red curve in here, it intersect the y-axis once right here, the point that I try to make it big, we will have 1 y-intercept. Okay, with the same logic, we're gonna have 3 x-intercepts in here and 1 y-intercept in here. And again, if you want to try for yourself, go ahead for it. Think it in your head. Let me finish writing x-intercept and y-intercept, and then I will tell you guys the answer for the last 2 pictures. Hopefully it match out with whatever you think of for the answer of the last 2 pictures. Okay, so for the third picture, for x-intercept, because it's only intersects once, so we have 1 in here. For y-axis, we have 2. And again, for the last picture, the circle doesn't intersect the y or the x-axis at all, so we're gonna have 0 for each. Okay, if you have any questions on this one, make sure you make a screenshot of this picture, like on the video, and just group me it, text me, or like email me about this to ask me for clarification. Okay, so for example 2 in here, I want you guys to find the x and y intercept for the graph of the following equation. So for this one, you have the graph already. It should be the graph of the very first picture that we did in a day in page 1. And this equation, if you can recognize it, is from the first example. It's from example 1 from last page. So if you have the graphs already, you can like check on the graphs and tell me the x and y intercepts of each graph. But further than that, I'm going to show you guys another cool way to do this thing. Okay. For the x-intercept, to find it, actually we don't need to look at the graph. We can look at the graph to double check whether our answer is right or wrong. But the very first thing that comes to my mind is that we know that x-intercept has 0 coordinate as 0. I mean has y coordinate at 0. So what we're gonna do is that we let y equal to 0. And another tip is that if you notice, for x-intercept, we're going to let y go to 0. And for the y-intercept, we're going to let x equal to 0. Simple enough, right? So for our x-intercept, again, we let y go to 0. And we plug it into the equation. So we're going to get 0 equals to 8x plus 10. And then we do our math. So we minus 10 from both sides. And then we divide it by 8 from both sides. And then we're gonna get x equals to 1. Whoops, this should be 8, not x. So we're gonna get x equal to 1. So again, I told you the x-intercept here, it could be a point or the x-coordinate, right? So you can box this as the answer for the x-intercept, or if you refer it as a point, you can write it as 1, 0. Why is that so? Because x in here is 1, we know that. And y in here, from the beginning, we let it equal to 0. So that's why we have the point as 1, 0. Okay. Let me get this picture out of the way so that we have like more space to do the y intercept. For the y-intercept, we're going to follow the same procedure. Just a heads up, because I'm running out of space, so that's why I'm running it on this space in here. But it's not the answer for this problem or anything, okay? Like the second problem is your part. I'm gonna do the first part of the problem. If it has to form like 2 columns like this, for the second part, you have to do it and submit it to me, okay? And just a heads up, you don't have to like redo what I do in here. Say like I did this part already, the first part of the example 2 already, so you don't have to do it and then scan it and then submit it to me. No, you just have to do this part only to submit it, okay? And the same will go for like the rest of them. If you have just one example, like example 1, that means it's your part. Like if I don't do it in a lecture, that means you have to do it to submit it. If I do the examples in the lecture already, That means you don't have to submit it. Okay. Okay, to continue the second part to find the y-intercept of this equation right here, oops, this equation right here, we're gonna do the same procedure for y-intercept. We're gonna let x equal to 0, and then we pretty much just plug it into this equation again. So we're gonna get y equal to 8 times 0, because x is 0 now, and then plus 10. Right? We all know that 8 times 0 is 0, and then 0 plus 10 is 10. Let me just write all of them out just in case, like this might be too fast, or something like that. Okay, so as for the final answer, as I told you, the y-intercept, again, it could be a point, or it could be either a point or the y-coordinate, right? So you can box the answer of the y-intercept as y equals to 10, like this, or it could be rewrite as a point. Since y is 10, the second part will be 10, and the first part should be 0. Again, why is that so? Because we have x equal to 0, the 0 right here, and then y equal to 10, the 10's right here. Okay? In the test, if you can, please give me 2 answers, both as a coordinate and as a point. I would appreciate it more as a point, but like if you're not sure which one you should turn in for the correct answer, for the final answer with like all credits, full credits, please give me 2 answers. Okay, let's move on to the next page. Okay, so just a heads up, there's nothing much on this page, but like just a heads up in case like in the future you might encounter more than just linear equation and quadratic equation. You might be dealing with cubic equation. Then I'm gonna tell you ahead like how it's gonna look like, so that you can like foretell yourself how many points you need to do it, and like the shape of it. Like if I give you like 2 points like this and that, and I told you it's a line, then you can do this, right? And with the same 2 points that I just did, let me change the color. If I told you it's not a line, it should be a parabola, it is a quadratic equation, you can give me some picture like this, right? Because I should say like sketching, right? It's not like graphing correctly, like 100%, no, it's just like sketching. Or like if I say it's a cubic function, then you could do something, I don't know, like this. Okay, it might be a really bad drawing, but yeah. Like as you notice for cubic equation, it looks like a worm or something like that, like it is wavy, but it's not like too wavy, like just from from the bottom you go like curvy and then up top. And another form of cubic equation, it could look like this, or even like this with like more waves. But don't worry about like that right now too much, because we're not going to go in depth into the cubic equations. Okay, and other functions you could see in this class, it should be absolute value, where you have a v shape like this, and the symbol for it would be it's just absolute value, the 2 bars with the function or like equations in between the 2 bars. Or a typical equation, the typical equation of it would be 1 over x, and the graph of it would be like 2 arc, like opposite to each other. Another one is that another one that you could see in this class also is the exponential. I believe we're gonna learn it toward the end of the class, not now. But yeah, if you can remember the parent function, like these graph in mind, the shape of it, not just the equation of it, that'd be great. I'll just make sure you take a screenshot of this one and keep it during the test or the quiz. Okay. The equation of exponential equation, it is e to the x. A quick like way to remember it is that if you know that it's already have e and x in the English word of it, right? So it's just e to the x, and it's like the cubic equation in the sense that it's like the top part of the cubic equation. If you notice, if not, it's fine. It's just like my way to remember things. And the next one is logarithmic. Again, we're gonna learn about logarithmic equations, but it's toward the end of the semester. Okay, exponential and logarithmic, Later on in the course, we will talk about the relationship between the two equations and how they relate to each other in the sense that they are inverse function of each other's. For now, the word inverse function might be a little bit too like complicated, but trust me, it's not that scary. Okay, and another kind of like inverse function of say quadratic equation would be square root this equation in there. And talk about trigonometry when I have like sine, cosine, tangent, even cotangent, secant, and cosecant. But again, you don't have to memorize all of these, okay? You don't have to memorize and like all the graphs in here. They're just like parent function. They are just there for me to introduce to you guys, so you guys know that they are there, you know. But for sure, there are 3 graphs that I want you guys to memorize for now. Let me put it in, I don't know, blue. You have to know the linear. Okay, like the linear equation is a line, so you better know this one because like it's just obvious it's a line, right? So you have to memorize that, like the linear equation will give the line as a graph. The second one is the quadratic equation. It will give the graph as the U shape. Could be an upward U shape or downward U shape. The third one and last one I want you to remember for like today would be cubic. Okay, those are the top 3 things that you have to memorize for this class. Another important equations that I would recommend but not like forcing you guys to remember is the reciprocal equation and square root equation and absolute value equations. Those 3 are important, but I would say like you don't see them too much. You shouldn't see them too much. At most, you guys will see them for like I don't know, like 30 or 40% of the course, but not as usual as the first like 3 that I draw in blue. And the last 2 equation that I really hope you guys can remember, but like toward the final, not in the first exam or the second exam, I hope, but for the final only would be the exponential and logarithmic equation. For now, you don't have to worry about exponential or logarithmic at all because I know they hard and they like different symbols. But for now, make sure you remember all the 3 equations in blue, and if you can, try to squeeze it in your like the back of your head, the 3 equations in orange. That'd be great. Okay. Okay. Next objective: circles. So we talk about lines. We talk about curves. Another form of equation, or not even equation. Another like form of like sets of points, collection of points. We have circles. So the special features of a circle would be the radius and the center. Let me like circle that in here and here. If you notice, a center in here is a point, right? And a point, any point, every point has an x coordinate and y coordinate. Specifically for center, we want to make it special. So for the x part, we call it h, and for the y part, we call it k. Okay, because you know, like for x and y, just like any random point. That's why we want to make it special. We want to give it like a special name for the center. That's why we like run out of letters and we go in for h and k. For radius, the symbol for it would be r. R for radius. We all like know that, so that is all right. We have okay. So the way that they come up with the equation of a circle is that they measure it by the distance formula. If you notice the distance, okay, let me redraw a circle in here. So we start with a circle and then we have a center. Okay, if you notice, the distance from the center of the circle to any point on the circle are the same, right? Because they all are radii. There's just one radius. Like if this distance right here is 1, then this distance right here is also 1. 1 in here, 1 in here, and 1 in here. Okay, if I change one of them to be 2, then all of them will be 2. They all should be the same, right? Else we're not going to have a circle. It's going to be like a little bit off from a shape of a circle. Okay, so with that in mind, we have the distant formula back in the day of like, I don't know, like college algebra or something like that. As a reminder, the equation or the formula of the distance, it is x minus x1 if you have like a point or something like that. In here we have the center, so that's why x1 in here would be h, and y for like the variable, and then the second coordinate of the center, which is k. Each of them will be square. That's why we have the square in here and in here, and then we add them together, and then we'll take the square root. Okay. For the distant formula, if you have to ask me, you don't have to remember it for the test. And actually, you don't even have to remember it at all. But like you will see something familiar, something like alike, that formula, that distant formula, when it comes to the equation of the circle. Why is that so? Because if you notice, we actually take this equation and we square both sides up. So on the left hand side, we're gonna have r becomes r squared, and on the right hand side, the square will take out a square root. That's why we don't have any square on the left hand side in here. And then we calculate, like finalize the deal with this formula in here. So for any point xy, any random point that has the coordinate xy, lies on the circle of radius r and a center hk. This to tell you that the circle in here, it has radius r and center hk. Okay. If and only if the point xy, the radius, and the center satisfy this equation. Okay, so you must remember this. Okay, later I'm gonna like start up all the examples that you have to do for, or like you have to turn in for the attendance or like the worksheet. But for now, let me just put it in like a different color. What color I haven't used? So, okay, here, let me do the highlight in red. Okay, this formula in here, you must know it for the test. Okay, you must know it for the test and for the quizzes. That's just a heads up. Okay, so make sure you like jot it down, like make a star to it or whatever you want to call whatever you want to do with it. Make sure you remember this formula in here. It's really important. Okay, and just imagine if your center is not like in the middle of the graph like this. If your circle is like right here, like in the middle of the xy axis, and you have like the center lies exactly at the origin, then the center in here, h and k, would be 0, 0. The radius, it could be like as big or as small as you want a circle to be, so it could like variate. But the center, say if it has to lie on the origin, then we're gonna have this formula in here. Why is that so? Because when h becomes 0, x minus 0 is just x. So we have x squared in here. And then when k becomes 0, we just have y minus 0. So we have 0, and then it's just 0 squared. And then on the right hand side, we still have the radius squared. Okay. In general, we're gonna have this form in here. Like if you have time and you want to expand this form out, you're gonna have this form right here. What do I mean by expand it out? I mean like literally write it out as x minus h times x minus h. And if you guys still remember what FOIL means, just do like this, that, and then the other two rows for the first term only, and then you repeat the same procedure for the second term, and then you connect all of them together, and then you're gonna have this formula pretty much in here. Okay, I mean, if you want, you can do it for fun, or you can look it up. The proofs on the internet is everywhere there. And if you notice one thing, for circle, they will have the same coefficient, or like the same front number for x squared and y squared. So if I give you something like, I don't know, like, okay, let me write here. 4x squared plus 4y squared plus blah, 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 blah. This is the circle, okay? But if I give you something like 4x squared minus 4y squared plus blah, 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 this is not a circle. Why is that so? Because the front number for the x in here, for the x squared in here is 4, but the front number for the y squared in here is actually negative 4. So it's really psi sensitive in the sense that a psi negative or positive in here, it could change your whole problem. It doesn't have to be like that much of a different, like, like if I have a 4 in here and if I have a 3 in here, obviously that's not a circle because 4 is not 3, right? It could like trick you out by saying 4 and -4. It could make you think that, oh, I see 4 and 4 in here, so they should be the same. But no, if you have a positive 4 in here, then it's a circle. But if it's a -4, then it's not a circle. So make sure you watch out for it. Okay. And a special thing in here is that a in here, it has to be different than 0. Because if a is not like different than 0, if a is really 0, then we're not gonna have a x squared or a y squared, and we're just gonna have like the second part, which is dx, ey, and an f, right? So that's pretty much a linear equation. It's not gonna be like a circle at all. So now, oh, like another thing before we get into the third example is that to change from a general to standard form, oh, for the name, the first formula that I want you guys to remember, that's called the standard form. And the general formula is like the expanded version of the formula. But I would recommend you guys remember just the standard form of the circle, because that's the most like useful equation in this class. Okay, so to do that, we have to complete the square. I'm not sure how many of you guys remember the process of completing the square. That's why I give you like a quick example in here for completing the square. I'm not gonna like go through this in the video, but I really hope you guys can read this, because it's like a little like push. I give you like a little push for homework help. It gives you the step in here to do it with explanation, and this is the problem, this is the solution. If you have any question on this one, you can contact me, you can ask me, take a screenshot of this one, just ask me to explain it over again. If you want to, I can do that too. But this process is very, like, I'm not gonna say it's hard, but it's challenging, to be honest. Like, with my experience, out of like 10 students, I would say like 6 students have problem with completing the square. Okay, so I would recommend you guys like pay like really big attention to this one. Okay, even though it's just an example, but you have to know how to do this example if you want to pass the tests and quizzes, right? So let's get back to the example 3 that we had earlier. So because this is like the 2-column example, this is my part. I will do the first problem, and this is your part. You will have to do this problem to turn it in. Okay, so for this one, as you guys can see, it looks more like the general form, right? So we have to convert this general form to the standard form of the circle, and after that we're gonna know the center and the radius of the circle, and after that we're gonna get the picture down. Okay, so very first thing, we have to classify the x term and the y term out. Okay, so we have one x term, we have 2 y term, and we have a number. Okay, there are 3 categories: the x category, the y category, and the free number category. Okay, make sure you classify them out all first. Okay, first thing first, the easiest thing. Okay, first of all, let me backtrack this one. Okay, so I know that is -10. Okay, circle again. Okay, the very first easy thing is that we're going to move the free number to the other side. So we're going to rewrite everything. 3x squared plus 3y squared minus 6y, but then move the other number. Moving in here, it means that you add 10 to both sides, okay? And after that, okay, this one is an easy problem, but for your problem, as you guys can see, you guys have like x in here, you guys have x in here, so it's like a little bit more challenging. That's why I will highly recommend you guys read like the example on page 6 before you guys do this example on your own, okay? For my example, it's pretty simple because I only have like one x term. So the x part is kind of like completing the square by itself, in the sense that I can rewrite this as 3 times x minus 0, because x minus 0 is just, x, right? And then square. Okay, why do I want this? I want to make my equation looks like the standard form, in the sense that the number has to be out. If you have any number in front of x, they all have to go out. And in the parentheses, you're going to have x minus a number. After the parentheses, you're going to have the square. Okay, and after that, you're going to have a plus sign here. And you're going to have like some front number. If you have something in front of like y squared like this, it should be like 3. And as expected, in the second parentheses, we should have y and then minus or like plus some number. And outside of the second parentheses, we're going to have square. Okay, so how can I make it happen, right? This is hard now. So once you put 3 out, that means we have to factor out 3 from all the y terms in here. Okay, so for the very first term in here, 3y squared, if you divide by 3, you're going to get y squared. Right? Not a big deal, right? For the second term right here, note it, watch over the sign, okay? Like, if it has a negative, make sure you include it. The positive, like, it doesn't make a big deal, but for negative, make sure you don't ignore it. Like, make sure if you see a negative in here, you have to write a negative in here, okay? Don't just, like, look at the negative in here and just, like, forget it, throw it away, and then you write a positive in here. No, it's not going to work, okay? So we have the second term in here is negative 6y, right? We divide it by 3, then we're going to get negative 2y. Okay? And so far, it's still like okay, right? Like decent, good, right? Now, let me take out the parentheses. And, okay, let me make the parentheses like bigger a little bit in here so I can have space for the third number. Why do I say the third number? Because for completing the square, we will have 3 numbers. Let me put it in another color. Let's use orange in here. How do I know the third number? Like, how do I know how to compute a third number, right? Here's the procedure. First of all, you're going to grab the middle number in here. Take it, divide it by 2. Okay, so this negative 2 is from the number, and this 2 is from me because I'm telling you to divide by 2. Okay, and after that, we're going to get negative 1, right? And after this, that's first step, right? Second step, you take negative 1 or whatever number you have, square it. So we know that negative 1 squared equals to negative 1 times negative 1, which is 1, right? This is the third number that we're looking for. Okay, now what do we do with it, right? We're going to do plus 1 right here. And just a heads up in here, the sign of the third number is always, always, always positive. So it's always plus something. Okay, and back to the right hand side. Okay, let me erase some of the work in here first. Okay, let's get back to the right hand side. So we have like equal sign here, and we have 10 in here. But don't stop in there, okay? Because if you stop in there, that's a big mistake. We just input plus 1 on the left hand side, right? So we have to do something to the right hand side to keep it balanced. It's like, it's not fair for the whole equation because you like add on something to the left hand side, but then you don't do anything to the right hand side. Okay, so okay, I used to make a big mistake. I used to do plus 1 in here. That's wrong. Don't do this. Okay, this is really wrong. Don't do it. I will tell you guys why it's wrong. So if you notice, there's like a parentheses after the 1, right? It means that the 1 in here is trapped inside the parentheses. So it means that if you want to like add it to the other side, you have to free it out first. What do I mean by free it out? In front of the parenthesis, the open parenthesis, we have number 3, right? So we have to do 3 times 1 in here, which is 3. And this is the number that we add on the other side. Okay. Or if you want to make it more clear, here, let me change the color again. Okay, let me erase this one. Let me do 3. Okay. and then times 1. Okay, now let me use, I don't know, like brown here. This 3 is because the front number of the parentheses is 3. And this 1 is because the third number in here is 1 coming from here. Okay? After that, that's the hardest part. Okay? Now the easier-ish part is that we're gonna rewrite this one down because it looks like the first part already. So we have 3. This one doesn't listen. Okay, and then x minus 0 square, and then plus 3. This is my square, but it just doesn't look like a 2. Okay, inside the parentheses. Now you have to ask yourself if you still remember how to factor the group. Okay, the easy trick in here is that you can graph the y in here because it's a y variable, and if you notice, the second parenthesis is on about a y. And then the middle sign, if it's like negative, then you would write a negative in here. If it's positive, then you write a positive in there, okay? And the third number, let me change the color. There, okay? And then the square. Why is that the square? Because like in the form, it has the square in here. Okay, that's like the complicated way to remember it. The easier way to remember it, let me put it in, I don't know, like blue, is that think about the x method that you did like in a day. Like you have to choose, like you have to find two numbers that multiply to 1, but then add to -2. What are they, right? -1 and -1. -1 times -1 is 1. -1 plus -1 is -2. So we have -1 in here, -1 in here. Ta-da! -1, 2 times 1 and 2. That's how I prefer to think about it. Okay, but like there's 2 ways to think about it. I don't know, like whichever way that you want to think about it is fine. And then now moving on, we have the right hand side. So we have the bridge or the equal sign first. And then we're going to put all of this into the calculator, or if you want to do mental math, you can just do it. So 3 times 1 is 3, and then plus 10 is 13. Okay. And lastly, the very last step, I know this is long, but yeah, the very last step for like this example is that notice that in this form right here, we don't have any front numbers in front of the parentheses, right? That means that we have to divide everything by 3. So this 3 is out, this 3 is out, and then the number in here should be also divided, right? So this is gone, this is gone. Okay, so then this is the form that we want. If you want to make it like finalized, you can box it. Make sure you rewrite the equation. Don't just do it as like lazily like me, just like cross out the 3's and box it. I'm running out of space, that's why I'm doing it like this. But in the quizzes or in the test, make sure you rewrite it and then box it. Okay, don't just like slash them out and boxes like me in here. Okay, so how can we draw the circle? What is the center in here? And what is the radius in here, right? So this is the x part, this is the y part, but make sure you change the sign a bit. So for 0, we just have 0, right? It's not like -0 or +0, it's just 0. For the y coordinate in here, we have -1, but if we change the sign a bit, we're going to have 1. Okay, so this is the center. And as for the radius, if you remember in the formula right here, I like trace it out too much already, so then you guys can barely see the formula, but it write r squared in here. It means that this number in here equals to r squared. So if you can put it into the calculator and do square root of 13 divided by 3, that will give you r as the radius. So let me write the radius in here. Okay, let me use my calculator and do it out really quick. Okay, I got 2.08. So it's around like 2. Okay, how do I draw it? Okay, first of all, let me erase some information in here. Okay, let me put in another color. Brown, I don't know. So we have the coordinate x and y, right? Make sure you label them. This is x, this is y. We first get a center, 0 and 1. So x is 0 and we go up 1, make a point, call it a center. Okay? And then the radius in here is 2.08. Like, it's roughly just 2, right? So from the center, you go to the right by 2, you go to the left by 2, you go down by 2, you go up by 2, you connect all the points together. Voila, we have a circle. Okay? So what do I expect from this example? I'm expecting, first of all, the final like form of the circle, and from there you have to tell me the center of the circle, the radius of the circle, and then the graph. 4 things. Okay, here's your turn for this example right here. Okay, moving up next, we have number 4, and if I'm not wrong, it should be the last example of the day. Okay, by the way, for 5 for mathematical models, I give you some like examples and I show you guys the solution. It says optional, right? Whatever says optional in my notes, that means you don't have to do it. I mean, you can read it for fun, you know, like all this is relating to business calculus, so you might encounter it if you work for like some fancy I don't know, like company in the future in the field. But I don't know, right? So that's why I put it optional, because it's not as important as the other objectives of the day. So you don't have to turn this into me. Like, if you want, you can do it, but you don't have to turn it into me. Okay? And for this, I find it's really interesting. Again, since we're talking about business, like, you're gonna have to know what it means by the demand and then supply equations and all that information, right? Just for future use in the field. And I give you an example, but again, you don't have to do this because I already give you the equation. If you want, you can read it for fun. Okay? Okay, let's talk about the last objective of the day. Points of intersection. So if you guys still recall the example I gave you guys earlier about like the street. Okay, this is not the best way to draw the streets, but yeah. Just imagine like this street in here is a vertical line, and then the other street in here is a horizontal line. They intersect at the intersection, and this is what we call by the intersection point, or point of intersection. Okay. So a point of intersection of two graphs is an ordered pair. Okay, so it's a point, and a point always have like x and y. That's what it means by an ordered pair. That is a solution point of both graphs. A common business application that involves points of intersection is break-even analysis. You can Google it if you want to, but later on in the course, we're going to talk more about break-even analysis. That's just when you try to invest your money into something and you don't want to like have any like loss in your like investment, right? You want to at least make it even. At least, just like if you invest like $100 into something and then you keep seeing it going like not in the way that you want it to be, at least you have to get your like $100 back, right? Not like just lose them all, right? That's what it means by break even. Okay, the marketing of the new product typically requires an initial investment, just like any other field, right? Like anything needs or requires an initial investment, especially when it comes to business. When sufficient units, like products, the amount of products, the word units in here is like shirt or like cars. It's just like the product, the amount of products have been sold so that the total revenue has offset the total cost. The sale of a product has reached the break-even point, and the total cost of producing X units of a product is denoted by C for cost. So let me underline this. Okay, and the total revenue from the sale of X unit of a product is denoted by R. Okay. So just to break it down a little bit more about the meaning of English, I might be wrong on like interpreting these English words, okay? Because those are not like super like math terms. But if I write, then the cost in here is like the cost of like a car is like 100. That's what you have to pay for, right? The cost is not your money. It's the money that you have to pay to get what you want. And the revenue in here is like, I don't know how to explain revenue too much, but if you look it up on Google Translate, I guess, or like definition of revenue, that will tell you what a revenue means. Okay, so let's get to the first example. If we have to find a break-even point, how do we do it, right? So we have the cost in here. Okay, it costs a business $29 to make a pair of jeans. For the jeans, the fixed costs like insurance, labor, or like all the fees like that come to $1,000. The store sells the jeans for $49 per pair. So how can we get the break even point? Okay, so as we learn in here, for break even point to find it, we have to know the cost function and we have to know the revenue function, right? We have to know how much we have to pay for and how much we have to, like how much do we get from each product. Okay, so for the cost in here, this number is for the cost definitely, and the fixed cost in here, this number is also for the cost. This number in here would be for the revenue, okay? Because the $29 is like how much you have to pay, the $1,000 is how much you have to pay, and the $49 is how much you earn for each pair of jeans, if that makes sense. Okay, so for the cost equation, let me write C in here for cost. Okay, like to my experience, for every time you see the word per, it means that number should be attached to an X. Okay, and if you see like fixed cost, usually that's a free number. Okay, so 29 here is like you it costs you $29 to make a pair of jeans, right? So it's like per pair of jeans. So that means you're gonna have 29x. And the fixed cost in here is $1,000, so it's gonna be like plus $1,000 in here. Okay, and the revenue is like how much you get for selling the pair of jeans. And in here, since it has the word per, it's gonna look like 49x. Okay. Okay, so honestly, when I was a student, I really hate the word problems because they look like complicated. I don't know what to do from like right at bat. But like if these tips can help you, that'd be great, right? Like, yeah, like if you can understand the meaning of what you do, that will be even like better. Awesome. So break even points, it means like you don't lose your money, right? Like you pay for the amount of money and at least you want to get like zero loss, right? That means the cost and the revenue should be equal to each other. With that saying, I'm gonna set them equal to each other. Okay. So we're gonna get, let me use the space in here because like this will be your work. So we're gonna get 29x plus 1,000 equals to 49x. All right, so we're gonna do some algebra in here. We minus both sides by 29x. And after that, we're gonna get 49 minus 29, that is 20x, and equals to 1,000. So 1,000 divided by 20. My tricks in here is that if you want, you can cross out a 0 from each. So 100 divided by 2, we get 50. Okay. So we have the x coordinate, but since they're asking about the points, and again, a point would require x and y, right? So x coordinate is not enough. We have to find the y coordinate of it. So you have two options in here. You can either plug x equal to 50 into the first equation, the cost equation, or the second equation, revenue equation. Okay, if you're lazy like me, I would go for the short equation. So I'm gonna plug x equal to 50 to the revenue equation, and I get my y equals to 40 times 50. If you input into your calculator, we should get 2450. And since they're asking about a point, we should like put them as a point, right? And again, it's always go like X and Y. And then we're done. Okay, so mathematically we done, but then like I want us to understand more about the meaning of the graph. That's why I graphed this in here. Like if you want, you can graph it out in GeoGebra or Desmos, like technologies these days, right? So if you input the equation y equals to 49x, you're gonna get this line. And then if you input the other line, y equals to 29x plus 1,000, you're gonna get the other line. Okay, let me stop tracing it so I see the color. So in here, the revenue would be in blue and the cost will be in red. Okay, so whenever like they intersect each other, we call it break-even point. And if you notice, the point that in the graph looks exactly like what we got in here. So we know that we are correct. Okay, so at any point that your revenue is higher than your cost, that means you're earning, right? Like you gaining more money than the money that you invest. That means you have more profit. Okay, but if at any point your cost is higher than your revenue, it means that you're paying more than what you earned. That means you have a loss. Okay, so that's pretty much the meaning of the break-even analysis. So here's your turn. Make sure you do this example, and like I promised before, let me try to use another color. Okay, let's do, I don't know, like green. Okay, so you have to do this example. This is example 4. I numbered them. If you like notice, like for all the pages that has like number 1 to 3, for all examples that have the number, that means you have to do it. So for this worksheet or for this section, you have to do example 1, first start, example 2, right here. You don't have to do the first part of the example 2 because I already did it. And then example 3, this right here. And then lastly, example 4, the one that I already started, right here. Okay, so what do you have to turn in for the worksheet for the attendance? For 1.2 is the 4 problems. Okay, and like I said before, this page is just self read if you're interested in like equilibrium, price, or like other analysis in the business field. And the last page is it's just mathematical models if you want to read more about business. Okay, so that's it for 1.2. And if you have any questions, please don't hesitate to ask me at any time. You can pause the video to make a screenshot and just email it to me to ask if you have like any moment in there that you don't understand what I said. Okay, thank you and have a great day. Bye.